Okay, now we just wanted to know what is the reaction forces on the wheels when a car is actually trying to make a turn, and the details are given here. The car has got a weight of 1000 kg, which is shown here, and it has got a velocity of 72 km per hour. 72 km per hour can be converted as 20 meters per second, and radius of turn is given as 40 meters. Radius of turn is given as 40 meters. We know the formula for the centrifugal force, which is mv square by r. So m is kg, and this is 20 meter per second whole square. So it becomes 40 meter per second square whole square. So let me zoom this a little. Okay, it becomes 40. So finally, guys, you get this answer as centrifugal force is actually 10,000 kg meter per second square. You know this kg meter per second square is what? 1 Newton. So you can write this as 1 Newton. So centrifugal force of 10,000 Newton, which is approximately 1000 kgs of force. 1000 kgs of force being applied. And if you apply 1000 kgs of force, do you feel this car will topple? Car will topple? Do you feel that if I apply a force of 1000 kgs from sidewards, the car will topple? Because according to this equation, I just found out that by mv square by r formula, I just found out that this centrifugal force which is acting, by this formula it gives a force which is equal to 10,000 newtons, which is approximately equal to 1000 kgs, 1000 kg force. The weight of the vehicle itself is how much? 1000 kg. I am applying a force 1000 kg here. So for that I need to know the height. Only based on the height I can say whether it topples or not. Okay. So now there are two ways you can actually find out. So one is trying to create a clockwise movement like this and an anti-clockwise movement. That can be done. You will try to solve the problem in that way. Okay, in the next that's in the next video. But right now we will try to see what is the reaction on all the four wheels. Okay. Then once you have this force, it will try to create a couple about this, like about this wheel. It will try to topple like this, about this wheel. Okay, about this wheel, what is the distance? The perpendicular distance. The perpendicular distance is equal to this. So it is centrifugal force into h. So which creates a couple like this. So centrifugal force is here, which actually creates a couple. That couple is, since the height of this center of gravity is 1 meter, so you get the couple which is equal to 10 kilonewton meter. So that is the couple which is acting on the car, which is trying to topple the car. Now we use these terms, which is called as the reaction at the inner wheels and the reaction at the outer wheels, which you call it as Ri and R naught. People also call it as Fi and F naught. And finally, in the formula, I don't call it as F or Fi or F naught. I simply call it as the centrifugal couple is equal to track width into force. Here, you know that a force is trying to topple this like this. So now this centrifugal force is equal to the centrifugal couple into height. So that is this, and this can be balanced by two forces, R naught and Ri, which is at the distance W. So I can actually equate this to this equation where F is equal to the track width, the force on each wheels, the outer wheel or the inner wheel, into the track width. So suppose if I equate this, then depending upon the track width, so the track width gets divided here. So meter gets cancelled. You are left with newtons here. So you get the force of 5000 Newton here. 5000 newtons is around 500 kgs. So it's around 500 kgs of force which is acting based on whether the wheel is inside or outwards. When a car is actually trying to take a turn to left, a car is trying to take a turn to the left, which wheel is inside and which wheel is outside? Basically, left wheel is inside and this wheel is outside. Which wheels will lift? Guys, it's so common sense. A car is trying to turn like this. Okay, will it topple like this or will it topple inwards? It will topple outwards now. What is this? I think this is common sense. Huh? When you're going in a car, when you take a left turn, your body tries to go outwards. The car will try to topple like this. So the inner wheel will lift. Every time the inner wheel will lift, so it is always the inner wheel which is in problem, not the outer wheel. Outer wheel will actually get pressed downwards. Because when a car is going like this, it will topple like this. Okay, so now you want to know what is the force on the inner wheel and the outer wheels. You don't have to worry about the outer wheels, you just have to worry about the inner wheels. What is the weight on the inner wheel? You saw that since the weight of the car is 1000 kg, 250. Okay, so 1000 kg, it is actually 250 kgs, 250 kgs into 9.81. So that is the force which is acting on the inside wheels. Now imagine this car is actually going like this. Now the car is taking a turn like this to a left side. The car is here, it is the inside and it is the outside. The car is taking a turn like this. And the inside wheels will lift. The outside wheel will get pressed downwards. Because of the weight of the vehicle, which is 1000 kg. So 1000 kg, each wheel is 250 kg. 250 kg into 9.81 is 2452.5. So you find, you actually put the reaction forces like this. But because of this, the inside wheel will get lifted off. When you have a force like this acting downwards, the reaction force is shown upwards. So the outer wheel will get pushed downwards. So you add this 2500, this value of this force, 2500 Newton upwards here, because the force actually gets added onto the outside wheels. But for the inside wheels, the force gets deducted. So 2452.5 is the force which is actually trying to hold the wheel onto the ground, but the force which actually lifts the wheel out of the ground is 2500. So you will have this 2452.2500, which is negative, which means that at 70 km per hour, at around 72 km per hour, the vehicle will definitely lift off when it is going to turn with a turning radius of 40 km per hour. So 40 meters. So 40 meters, and that too I have given a very large track width. So can you see the track width here? So the track width given was 2 meters. Which vehicle will have a 2 meter track width? Usually a SUV. SUV will again have a larger mass. So I think 1000 kg cars like Maruti 800 and all these cars will definitely have a smaller track width, like 1.25 meter or 1.5 meter. So even having a larger track width, the car would topple. So always this forces on the inside wheels should be positive. The forces on the inside wheels should be positive. So if it is going upwards, that means the weight is acting and it's trying to force, it's trying to provide a reaction force. Okay, if I'm standing on imagine that I'm standing on a weighing scale. Okay, and suppose the weighing scale shows some weight. Okay, I'm 72 kgs. Suppose the weighing scale shows 72 kgs, so that means I'm providing a reaction, and the weighing scale is showing 72 kgs. Suppose somebody lifts me off with a force of 72 kg, then what will be the weight on the weighing scale? 0. It will show 0. So that means I'm not contact with the ground. Okay, so like this, suppose if foot gets attached to the weighing scale, still people lift me with the force of like 100 kg. Now what will be the value shown? It will be minus. Suppose if it is able to show minus, it will be like minus 28 kgs. Something like this. So when I show minus means, so that means the wheel is getting lifted off. You need some extra force to actually put it downwards. So like this, you try to solve this numericals related to the centrifugal force.